Our first main presentation is from Leif. So welcome Leif to Estonia. Leif is one of the most genius guy about woodland key habitats, and his presentation will show us, I think, many topics and questions about the woodland key habitat. So please.
Thank you. Okay, it's nice to be back here in Estonia. It was some years I was here. I was last year a short visit, but apart from that, it was a long time I was here. And it's a pleasure to be back and see all these faces and friends since years ago. Actually, it was 20 years ago we started this project, and I will make some looking back in the history and approaching our time, and also then look a little bit shortly into the future. It's not so easy to predict the future, but things are different now compared to 20 years ago, and I will go into that shortly. If we looking back, let's go back 140 years or so. We realize that nature conservation is not very old, actually. It is younger than the industrial time era, and it started as a result of all the impact humans are doing on nature. We usually say that the nature conservation started with creating the Yellowstone National Park in the United States. But actually, in the Western world, we always think we are the best. But if you look a little bit around, you can see, for instance, that in Mongolia, more than 100 years earlier, they created a nature reserve, which is quite big, and with the same purpose as our national parks and nature reserves. This was the beginning, somehow. If we go 50 years later, then the nature conservation activities have started in many countries, but it wasn't really a movement among people. It was professors and academics and people from the upper classes who were engaged in these things. And the sites selected for protection, there was like magnificent sceneries where you have big mountains and so on. They were like national emblems for different countries. And first protected areas, there were national parks. If we go 50 years more, the land use had intensified more and more, and it was obvious to a lot of people. There were starting movements, and nature conservation people you could find in all social classes, more or less. And the green movement was really growing. And it's because the landscape didn't look at all what it was before. Forests had been cut, the wetlands were ditched, and if you looked out all these meadows and pastures, they were impoverished by fertilizing and cultivating. So it was clear that a systematic conservation of nature should be necessary to preserve fauna and flora and fungi in the nature. And also you could see at the administrations in various levels that there were created authorities that took care of these questions. And for Sweden, let's say in the 70s, but also into the 80s, many nationwide surveys started. For forests, the first survey made in Sweden, I think it was the same in Estonia, you had some old growth forest survey. It was not so systematic. It was people were asked out in the region, do you know any big area which could be of interest, and so on. And then they were put into maps, and they made some very short notices of what it was. But it was a good attempt, and still many of those sites became protected area later. But it was too few sites, so of course you needed a much more comprehensive tool, comprehensive work to find out where you had areas worse while protecting. And what started more in Sweden was this wetland inventory. It has been done a very big inventory of wetlands. That's actually the biggest survey that was done in Sweden. It covering a very big area of Sweden. Wetlands in total is about 25% of Swedish land area. Forest is about half of the area, but the wetlands was actually the biggest survey done. There was also done a survey on meadows and pastures. Meadows and pastures had declined enormously during the 20th century. It was, at the end of that century, it was maybe like 5–10% of what it was in the beginning of the century. So those areas were really threatened. But then, in forest, our knowledge was too scarce, so it was started a new survey that really should go in deep with finding sites of biological value. That's how the Woodland Key Habitat inventory or survey started. And there are many problems during such work to find out if a site is worthwhile preserving for biodiversity. You must find the site in the geography, and you have different tools for that. Aerial photos is one such tool. This is an Estonian photo from the old time. It's not so far from here, I think, this place. But there is another tool you can use is this forestry maps and forestry databases. Actually, you had better databases than we had. We had perhaps a little bit better aerial photos than you had, but the forestry databases you had in Estonia, they were covering the whole country more or less, and they were they were in computers. You just could make criteria to select them out. And we did when we worked, and it was quite a good way to find many sites. But the second thing you should do when you once have potential areas of interest, you should find out, are they worthwhile protecting? Do they have any biological values? And for that, you need good criteria. And that's one very important point of this Woodland Key Habitat survey, to establish such tools and criteria. So we're talking about finding out sites with high nature conservation value. And this can be a concept which is not so easy to understand and to communicate, but when we have been working, it has been focused on what sites which are really contributing to the biodiversity And how much they contribute will give them different places in a ranking system. We didn't rank them very much in the Woodland Key Habitat survey. There were only 3 levels: those who were rejected and those were called potential woodland key habitat that could reach such values within a certain time, like 20 years or so, and also those that were real woodland key habitats. But you must be aware that when you are working with nature conservation, there are other aspects you need to take into account as well. I mean, sites can be valuable for recreational, educational, geological, and aesthetical points of view. So, for Swedish case and also in Estonia, you had a quite big task to visit a lot of sites and check are they woodland key habitat or not. And we had not in Sweden, and you had not in Estonia, and not in the other countries who have done this work. You didn't have enough educated or biologists that you could just put into work. So what was done is that we developed a method and we trained foresters to participate in this work. And it was a quite successful move because you could get a lot of people into the forest quickly. Just give them the skills they need to assess the values in the forest. But also the method should be fast. You shouldn't need to go there for weeks and checking all the lichens and mosses and fungi and insects and birds and whatever in the site. Then you would not reach your goal. You would not have a map of woodland key habitats. So 2 things was introduced as a help to assess the biodiversity values. And one of those tools was indicator species. Actually, this survey in Sweden, Woodland Key Habitat survey, was first out to have a good list of forest species that you could use for assessing the values. And those species should be easy to identify. They should be depending on values you are looking for, like old growth forests, special substrates, and so on. And they should not be too common, because then they have not so good indicator value. But if they also on the other side were very rare, they would not be very useful either, because you will find them once or twice during the whole survey. Then the second tool that was introduced was called key elements. And these tools are quite easy to learn. You don't need to be a biologist or know species to understand them and to learn them. It's rather quick to learn people to understand these things. So, we used a lot of such key elements. But one important part, of course, was to train these people, foresters and some biologists also, to identify the indicator species. And we used specialists on such species. We can see some of these specialists here in the room, to help to train the foresters. And I think it was rather successful. People really learned to know these species. And there are, of course, some species easier than other. like lobaria, and other were more like small dot, mustat tepid, I have heard sometimes during these courses we had here. It was, I can understand this, but in general people achieved good skills in rather short time, I must say. There was, these species were selected from red data books, but also from species we know are sensitive to forestry and human impact, but not so much as they became come into the red data books. In Sweden, we made it very easy for us, or difficult, you can say also. We call them all indicator species. You had one word for, you divided them in two groups, and I think that is more logical. I will come into that later. You called those who are not in the red data book, or were more common, like they were indicator species. The species in the red data books and other rare species you called habitat specialists. And that was logical, I think. Let's talk a little bit more about these key elements. And as I said, they are much easier to learn if you haven't been working with species before. And you have a lot of such key elements. You had snags, like biological key elements, like snags and logs and old trees. But then you had also physical key elements, like springs, rocks, streams, whatever. So these two, let's say, tools, key elements and indicator species, they were the main tools. There were, of course, other things we discussed in the field, like forest history and general human impact and negative human impact and so on, which also could influence the value positively or negatively. So let's look at the situation now in Sweden. In 1998, the main survey of woodland key habitats was completed. And this has later on come up to maps. We have one such map where you have all the woodland key habitats in a map. You can look at them in the whole Sweden. They are the red on the map there. The green areas are protected areas. Some of these woodland key habitats have been protected, some are not. But altogether, yes, I can say that I think about 300,000 hectares or something like that has been singled out as woodland key habitat in Sweden altogether. But then you must know also that additional woodland key habitat surveys has been done until today. There is going on work to complete the first big survey. We have in Sweden quite big archipelagos of islands along the Baltic Sea, and they were very difficult to reach. You needed boat, it took time and so on. So this was done during a period later on. And also some municipalities they were not done in a proper way, the first survey, so it had to be made again, so you find out what was missed. And also we have a lot of forest along the mountain chain in the north. It was also not done very well, or no, actually it was left out because we didn't have the resources to do that. And today, I heard that you are discussing whether it's a useful concept or it should be done or not, this Woodland Key Habitats survey. We have the same situation in Sweden. There have been a conflict up in the north, especially, whether you should continue this survey or not. The forest owner are against more surveys, despite the fact that the woodland key habitats, they are not protected, they are just found and marked on the map. But they don't want any survey anymore, and the green side in Sweden want to have them, because it's, if there are some very important places, efforts should be made to save those areas. So I think the work was more or less halted last year. Now we don't know. We have had this government mess in Sweden. We didn't have a government for quite many months. Now we have something, but we don't know what they will do with the key habitat in the North Sweden. If we take a situation in the Baltic states, this survey first started in Latvia. It was some start 1997. And 1 year later, it was also started somehow the project in Estonia. It was in Latvia, and the beginning in Estonia was made by Tommy Ek from Sweden, who came with this method from Sweden. 1999, I came here first time, and I worked with some of you then, and the big survey, it was not a pilot work, but the real survey started 2000, as I remember, with new people in the leadership and so on. 2001, the survey started in Lithuania. And 2003, rather quick, I would say, the survey was completed in Estonia and published. I see some of you had still this VEP report. It's funny, you have them still. I didn't bring mine, so I have some copy at home also. 2 years later, a similar report, and the work was completed in Lithuania. Lithuania is a bigger country than Estonia, but the forest area is more or less the same as in Estonia. So we could discuss a little bit what is good and bad in when you work with the forest in the way you do when you are doing surveys on woodland key habitats. One thing is that, a good thing is that it's a transparent method. You publish what you have found and everybody can see. So if you have done something wrong, there is up to some people to show it, or it can be evaluated by third parts. It's also a systematic survey. The sites are not randomly selected if somebody knows it or so on. It is made map by map, the whole geography. But there are problems working in the way you do with the woodland key habitat survey. This is a stand level survey. You go out in each stand and you look at it and looking for species, looking for key elements and so on. And it makes, the result will be rather small sites on the map. And for many species living in forests, they need bigger areas. And the result, if you protect only the woodland key habitats, it can be fragmentation. And this species will slowly actually not survive in the forest, despite you have protected the small spots. There is no landscape ecological aspects taking into account when you do the survey. And you can say, how could you do it? You don't have this knowledge. It's not easy to take this into account when you do this survey. That's like next step. I will come into that later. Another aspect of this is that we are always under some influence of forest owners and forestry who don't like these work, and they want the surveyors to be more, how to say, restricted to designate woodland key habitats and so on. And I think some foresters in Sweden couldn't withstand the pressures from forest owners and forestry sometimes. So the result were in such cases not so good. You could see that some persons didn't really do a proper work. Similar surveys have been done in many countries, actually. They are maybe not called woodland key habitats, but in Norway, some part of the surveys were called woodland key habitats. Other were, they had some conflicts in Norway between two different systems, but the outcome still became rather big areas surveyed. Finland has also done surveys, but I think they were more focused on bigger areas already from the beginning. In Denmark, they developed a method, but they have no forest, so not so much was done in Denmark. On the other hand, if you go to the east, you have a big country with a lot of forests, and making a stand level survey in Russia wouldn't be very successful. So, but the method to assess stands, if they are valuable for biodiversity or not, that can be implemented, but you must work in another scale. So actually, the method was introduced to Russia as well, and it's used by forest company who want to be certified according to FSC or other schemes. For me, this was a rather interesting journey to participate in woodland key habitat surveys in different countries, because you could see the method was developed by discussions with experts and persons in different countries. Always there was something that was could be improved, and people really added a lot of things into this. In Sweden, this came up with these two tools, indicator species and key elements. Already the Latvians understood that why don't you, I mean, there are two different kinds of species you use, habitat specialists and indicator species. Yes, it's quite logic. And when we came to Estonia, they classified this key element into landscape key elements and biological key elements, very logical as well. So, I mean, the concepts were developed during this process. In Russia, they had some other aspects they wanted to put into this work, and they wanted to look at the dynamics in the forest, if this was what type of dynamic and how the dynamics could be seen in the stand or in the place they worked. They also wanted to work with big areas sometimes, or massives, which is very logical if you have so big areas to deal with. So let's now jump to present day, 2019. Many countries have done surveys. They have, or similar surveys. We have in most countries solid databases where all the results are gathered. And most countries have had several editions of red data books. And the protection of forests has continued. Sometimes more higher speed, sometimes slower speed. But the result in the nature is still that the biodiversity is declining, especially if you look at the managed forest, which is like the matrix in the forest. And many species, actually, we had in Sweden 100 years ago, they seem to be extinct forever, like the middle spotted woodpecker and the roller. They haven't been in our country for decades now, or half a century. One thing should be mentioned, I think it's the same everywhere, it's that finding out or designating a place as a woodland key habitat doesn't mean that the site is protected. Not in any country's legislation, as I know. But they can be used in various ways, and if you have certified your forestry according to some, like FSC, then these key habitats can be voluntarily protected. It's a requirement for such certification, and then they more or less automatically should be protected. We should now try to look a little bit in the crystal ball and look at the future, because things now are different compared to 20 years ago. We have many service data in the databases. We have red data books, which are rather good and managed now. We have databases of findings of different species. So a lot of things can be done. And I will now show 3 different approaches which can be helpful when you continue to work with protection of forest or other landscape types. One is what we call density analysis. Another is called connectivity analysis, and that has very much to do with this meta-population theory. And also you can make gap analysis to see if there is enough of some habitat, or biotope, I mean, not habitat, when you can find out thresholds for existence of species. Let's take the first type. That's where you making maps in the of how certain things appear in the landscape. For instance, if you can make these maps based on how many species connected to some habitat you find per square area per grid, and then you get maps of that. You can also base these maps on the biotope itself, how much you have of it. I should look at some maps here. I have been working very much in the hemiboreal region in Sweden, and we looked in one study here of oak species. We selected focal species, 23 different species confined to oak, and we checked out from the databases how many can you find per square here of these oak species. And then you get a map like this, and you can see that there are some very clear concentrations of grids with high number of species. And so here you have important areas for oak biodiversity. while in southwest you can see there is not so much. Many of these squares are completely empty of these species. Here is the list of the species we used. It's 23 focal species. The Swedish name you can probably less leave, but the Latin name you should maybe understand. But there have been other surveys as well. Here is a map of single oak trees. There have been surveys of giant trees in Sweden where you, with your GPS, you mark all the trees which are over 1 meter diameter, and this is from the oaks then. Not all this area is covered by the survey. They are hatched. You see there are some areas not surveyed, but most of them are in southwest where you don't have so much oak. But along the Baltic coast there are also some areas with more oaks. And the concentrations are the same, as you can see, more or less. This can be done to single out regions where you should focus on protecting of oak sites. So you put the money when you buy land with oaks on the right place. Just because somebody is willing to sell you some oak stand in some other part of Sweden, it may be not the best use of money. The money will do better work if you are in the core areas here. Then we shall take the second way of working with this computer analysis. It's called connectivity analysis, and you understand that the landscape is more or less friendly to species if they should migrate to new places. And when you make such connectivity analysis, you put some figure on how difficult it is for species to migrate through different biotopes. Like if you take forest species, they are probably not so happy with urban areas and fields and water and so on, so you put a high figure. If you have some other, like wooded pastures and so on, you can give them higher value. The prerequisite to do such studies is that you have a biotope map of the landscape. And there are made such maps today. They are not very detailed, but in general they give some idea what, if it's field or if it's water, if it's roads, if it's urban areas, pastures, and so on. So if you have, you need those biotopes to make a map of the permeability for species. But you also must know if such a species, how they react on various biotopes. And it is, I mean, it's not so very well funded. It's like guessings, so it's not very hard facts you are using. But anyway, it gives nice maps. That's why with GIS tools today you can make a lot of maps. And you can be very much charmed of those maps, but sometimes they are more beautiful than helpful. One study we did was in, it is in Småland, it's a county in Småland called Kronoberg. We were using grasslands. And this is a study made on mesic and dry grasslands. It's about 4,424 patches of grasslands from one of those grassland surveys that were done. So you can see how they are spread in this county. And already here you can see that there are some clusters which are more dense than others, but you can develop this clusterification somehow. Let's look at one village with some patches of grasslands. Can look like this. When you put it into computer and you see there is forest, there is fields, roads, and so on, some lakes. When you put the figure on all those biotopes, you can get a map of how the ways you can theoretically think that species can migrate in this kind of grassland species. And then you get such electric red lines between. This is, of course, not very well corresponding to how they are moving in the geography. We are using, there are different tools. The Linkage Mapper is a very commonly used program. And this is an analysis called least cost path. But you can add another analysis to this, getting corridors, and this gives a more, how to say, probable, more in correspondence with reality, how, if there is any connection between these grassland spots, it will probably be better reflected by this figure than the other one. Here is one municipality in this study, and you see all the clusters as bigger patches. The green are these grasslands, and those where the connectivity, various degrees of connectivity, they are in various colors of green. The lighter, the better connectivity. But when you go outside this, there is no color, there is no connectivity if you follow this program. You can look into one big cluster like this, where there's a lot of grassland. Okay, then we shall take a third type of analysis you can do. It is a gap analysis and finding out the thresholds for existence of species in the landscape. You can assume that there is a correspondence between amount of habitat of a species and the probability of a species to exist in a landscape. And if you have good data of species occurrence and good data of the habitat of the species, then you can calculate what is the threshold for the existence of the species with a certain probability. And most or quite many species have this kind of curve for probability of presence if you have the habitat of the species. If you look at the right up there, it doesn't matter if you increase the amount of habitat, it's still there with more or less 100% probability. But when you go to smaller and smaller amount of the habitat, you see a sudden drop of the curve. It goes down to 0. And there, in the dropping, where the curve is going down, you can find out, let's say, with 80% of probability, how much do you need to have of the habitat in the landscape before it will be there. And we made studies of these 23 focus species, not all those. We had models for this, and these mathematical models didn't always bring a result because there was some lack of data. The presence of the species did depend on something else than the habitat, like the climate and so on. So to get thresholds with some statistical significance, you needed good data and so on. So here we represent some, I think it's 9 species, which really got good thresholds. And if you look at the blue line, there it's where we have made some average of all these species where we found thresholds. There's a lot of lichens, some fungi, and there should be also some beetle, Osmoderma eremita. We found out a threshold for those. And this threshold you can put into a map to see, is the landscape enough for those species? Do you have enough oaks? And here you could see on the green squares that there you have the species and there is enough oaks. So the landscape satisfies the needs for those species. But then most of the squares have other color or no color. So it means that the landscape only on small areas really satisfy the needs of these species. And we use this 80% probability for occurrence. The blue squares have enough oaks, but the species has not been found there, so we don't know if what this is. Is it forest history? So the oaks are rather recently become big enough, or is this areas which have not been surveyed on species? That can also be the case. And other are various degrees of gaps of this habitat. Here is a close-up of the same. And this analysis is also a tool to help to see where should we put the resources when you are protecting some kind of biotope, and where should we restore the habitat so the species can survive. I thought we should look at the Swedish species observation system, which now has about 67 million records of species, but I think we don't have time to that. But I can tell you that this is a good base now for such analysis as we have done. We just take out a lot of data and use them for such landscape analysis. Most of these records are birds. Bird watchers are more active than other people putting in data. I think about 70% of the data are bird observations. Environmental impact assessment. I will tell you just shortly that this is something most countries do. If you are planning a motorway or hotel or whatever, nuclear plants, power, water, different plants and so whatever, windmills, you should make environmental impact assessment, and then there you should find out what will be the consequences for different things in the society, including biodiversity, and to understand how they will impact the biodiversity. You must know what kind of biodiversity do you have on the site where you are planning something, motorway or whatever. So there should be some biodiversity survey to assess the importance for biodiversity. And there was a standard made for such how to do it, because if they are not done according to a rather strict standard, these environmental impact assessments can be based on bad data or good data, and this should be comparable and according to a standard. So it was done a standard for all nature types and landscapes in Sweden, actually, even marine systems and water or whatever. But you can see here that the logic is a little bit the Woodland Key Habitat logic. You have the biotope value where you have the key elements at the base. And then you have the species values. Do you have many species? Do you have red data book species? Do you have very threatened species and so on? And then you come to different places in this square, and then you can get out how valuable the site is. So the logic from the Woodland Key Habitat species survey has been used for many things, including this one. Okay, thank you. I have now used a little bit more than I expected time. I don't know if you had time for the question now or...
Yes,
Yeah, okay.
but you have actually time for showing this art portal, and if you like.
Do you want to see something? But if they maybe if they have a question, that's also...
But we have now plenty of time for questions, but please, we have to use a microphone to make a good recording. So please, questions.
Hello. My worry is towards nature is about population. According to Estonian questionings, 77% of population is already for nature. So I have an idea, and I hope you reflect it positively. The biodiversity could be followed, as nature is changing all the time, by people who have telephone apps to take photos and analyze and send to certain places, because quite honestly I can't see the nature surviving the industry that takes no prisoners without local people.
So you think your viewpoint is that humans on the place is important for the preservation of species?
Yes, humans who care about the home environment and already can use the augmentation with the help of computer technology. Should be easy, isn't it? Plus, of course, photos taken by known flying objects.
You have the microphone too close, so I can't hear. Maybe.
Sorry.
I can come here and hear what you said. That
Oh, that's such a nice.
you said so.
Yeah. Yeah, I do use. I imagine if I have a phone, and I have a phone with an app to help me. I go to my forest to pick mushrooms or whatever, and I can send data that looks interesting to me to some kind of center that has the algorithm, IBM Watson, whatever, and they can analyze the data coming from people. And you do understand what I'm getting at is the social viewpoint of protecting the nature. That's why I mentioned the 77% of people in Estonia who would potentially participate, making nature protecting data more easily available. And most importantly, this participation would make people feel that nature matters personally to them.
I agree totally that involving people in this discovery and work to find species is important for the people to understand and support this. There is already systems where you can send images to people, or later on maybe such automatic systems where at least some species easily can be identified. So this is a good thing, but it will be, I guess, overruled rather quickly by some other method. You can make DNA analysis out in the forest also, where you get rather complete lists of different things. It's not so much for the common people, but so things are happening all the time in how to gather data from the nature. But of course, it's important to involve people.
Thank you. Any more questions? Wow.
There was...
We have.
Hello, thank you for nice talk. Do you hear me? No?
I hear you. Don't have it too close.
You mentioned other very important values of the key habitats, like recreational, scientific.
Not only key habitat, all kind of natures, yes.
Yes. But do you know any studies which have quantified these values, especially of those key habitats?
No, I have no such clear answer of this. I think you have to find out yourself. It has to be invented in some way also.
Or
I think.
maybe you have some like practical experiences how people visit those habitats to see different kinds of forests or something.
There have been a lot of studies of how many visitors are going to different protected areas and so on, but
not about those key habitats.
No, I'm not the person you should ask for the result of such things.
Okay.
But of course, it's something to consider.
Thank you. Next.
Hello. You were speaking about woodland key habitats in Sweden, Finland, Estonia, Latvia, Lithuania, Norway, and Denmark. But how about other, let's say, European countries?
About?
Other European countries, how it is inventoried and the numbers over there?
I am not aware of any survey like this in other countries. I have been I've been working with French nature conservation people, and they have tried to influence this on the foresters there, but the process has been slow, so nothing has really started there.
Thank you. Next. This is your last possibility to ask Leif, because he will visit us next time in future. And we don't know when.
Terrified me. I ask quickly. Actually, maybe it's two questions. I'm wondering, you gave nice example how you use with different landscape analysis for this particular biotope with oaks habitat. But do you have another kind of examples for Sweden from other habitats where you use these specific tools of landscape level analysis?
Yes, this study from which I took the maps of oaks, we made 6 different biotopes we used for Fraxinus, Ulmus, and Archer forests. We used for grasslands, dry and mesic grasslands. We worked for pine forests on rocks, and we also made a study on rocky vegetation like this Viscaria vulgaris and such habitats.
Wonderful. But my next question is, is this regulated somehow by state interests or municipal interest? I mean, how we can apply it so well in Estonia? I mean, how it is financed, or who is the initiative to
Such
do
studies.
such studies? Yes.
Yeah, this was a project, a pilot project. It was financed by a biosphere area in the middle of this here in South Sweden, and we. To make this analysis, we needed a much bigger study area to get statistically significant data. If you only use small areas, you don't get enough data to make threshold analysis. You need rather big data to get like solid statistical outcome.
Thank you. Any more? I will ask then myself, what is your estimation or opinion of this topic? Which kind of forest types we should consider to protect or conserve more in our region, in Estonia?
Wow, that was a big question. If you have asked me 20 years ago or 15 years ago, I would have had a better answer. I must think back now and find out.
Or at least compare for Sweden, for example.
Yeah.
What type you like the most? I think this is the right answer.
Yes, I found here very nice broadleaf forest with Fraxinus, ulmus, and so on. Oak forest we have more in Sweden than you have. Also quite many wet forest and aspen forest, they were very nice here compared to Sweden. And for good spruce forest, you had, I liked very much that you had very fertile spruce forest, which were in an old growth stage. Such fertile spruce forests, they are more rare in our country. And the alvar forest also you have. We have also in Gotland, but you have, especially in Rappla, you have, they are really important things. Also some of them in Saaremaa. But Raplamaa to me was very interesting place with a mix of alvar forests and alvar and alkaline fens and so on. We have very few similar things in our country.
Thank you. Any more questions? If not, then you can show art portal, for example.
Yeah, okay, I could show this. I made before I came here, made a search in this Swedish system for registration of observations of species, all kinds of species you can put there, not bacteria, but or other things from algae, mosses, lichens, fungi, insects, whatever, worms and mammals and birds. I took out here this Gyalecta ulmi, which is quite nice lichen on broadleaf trees, and the blue dots means many findings. You can zoom in. Now we should do that, I think. So you find here, you can see how the blue dots are dissolving into more sites. They should do at least. So this is quite a lot of findings of this species. And you can see here concentrations of this species, especially along this shore of this lake Vättern, there are many such things, because there are a lot of pollarded ashes and elms here. Here are also nice areas, and here you can see there are also very big areas of such. It's old wooded meadows with pollards of Fraxinus and ulmus, where this species is quite common. It's actually a red data book species, but I think it is really, it should be on the red data book, because we have this Dutch elm disease now killing a lot of elms, and we have this dieback of ash as well. So both ulmus and Fraxinus are declining. They are actually put into the red data book because the speed of their declining is quite high, although they will not disappear from the landscape, but the old trees will disappear. Have you this Dutch elm disease and ash dieback I have seen here, but the Dutch elm disease? So you still have this beautiful ulmus here in your country. That's nice. We have in some parts still, here for instance, in the middle, I live quite near here. Here, the ulmus are not touched by this Dutch elm disease. So we still have here, for instance, in this small mountain, a lot of big and beautiful ulmus.
Since when did it start?
Pardon?
Since when did the Dutch elm disease?
When did it come? It was, I remember the first sick elms I saw about 1980 in South Sweden, in Scania, and then it has spread north more and more. So 40 years has this. It takes time, but and it's climate dependent. If there are more cold winters, the beetle is not surviving. So that's probably why they have not attacked the ulmus here. And also we have some elms also in the North Sweden. It's another subspecies in isolated places. There will probably not be any elm disease, but on the other hand, those elms are not very big. In South Sweden we have huge elms. You have them also. Okay, now I have exceeded my time here, so thank you very much.
Thank you very much, Leif. Have applause.